Simplify this trigonometric expression. Uh, One of the methods that I used before is factoring out common factors. I don't see anything that they have in common, so I'm going to have to rewrite these using identities. But before I do that, you may want to just multiply things out. So for example, here I'm going to just find the product of these two. So it's going to be 1. Remember that whenever I have conjugates, 1 plus tangent of x, 1 minus tangent of x, the outer and the inner cancel. When if you do FOIL, if you do distributive method, you're going to have minus tangent x plus tangent of x. Those will cancel out. So I'm going to disregard those and then just plus and minus. I have minus tangent squared of x. I still have minus secant squared of x from that term right there. Okay, now what can I do here? I note that whenever you have these tangent, sine, or cosine squared, think of your identities or your Pythagorean identity. So the Pythagorean identity, the first one, or the easy one to memorize is this sine squared of x plus cosine squared of x is equal to 1. Now it depends. Do you want to either involve tangent or do you want to involve secant squared of x? Okay. So if I go to my Pythagorean identity, let's say I want tangent like I did on the other problem. So to remember that tangent of x is equal to sine of x over cosine of x. So what I'm going to do is I'm going to take this Pythagorean identity and divide this term by cosine squared of x. And the reason why is because I want this one to give me that tangent squared of x so that I can replace it with this term over here. Right. But whatever I do to one term, do it to the other ones. Divide everything by cosine squared. This is plus 1 is equal to secant squared of x. And what we actually saw is a couple of things. Not only did the tangent square show up, but also the secant also showed up. Okay. So there's a couple of things that you can do with these. What I'm going to do is I'm just going to solve for just this term alone. If I do that, I'm going to move this over here and say tangent squared of x is equal to secant squared of x minus 1. Okay, and then I'll take a different approach right now. And what I'm going to do is this right here, I'm going to replace it for this tangent squared of x. So I still have that minus in front, so just be careful. And then I have secant squared of x minus 1. And I'm putting in parentheses so that you can make sure that, again, you identify that everything else stays the same. That 1 minus and that negative, I do have to distribute into both of these. So minus secant squared of x plus 1 minus secant squared of x. I'm going to combine like terms. 1 plus 1 is going to give me 2. And this negative secant squared of x is going to give me 2 of those. So I'm going to say minus 2 secant squared of x. Now what can I do? How? What do they have in common? Yeah, so let's factor out the 2. So 1 minus secant squared of x. Well, looking at this, yeah, because there's a couple of things that you could have done also. Since I decided to solve for tangent squared of x, you're going to see that it's basically involving a few more extra steps. I want to basically get this 1 minus secant squared of x. So I'm still going to go to this one, but instead of moving the 1 over, I'm actually going to move the secant squared over and the tangent squared over. So I'm going to say negative secant squared of x plus 1 is actually equal to, when I move the tangent squared, it's going to become negative tangent squared of x. Or some of you could just see it from here by multiplying by negative 1. Both of these, you should get that answer as well. So this one right here is going to get replaced with negative tangent squared of x. And then I still have this times 2. So my answer would be negative 2 times tangent squared of x. Let me back up a little bit to show the different approach that some of you may also do. If some of you recognize, like I mentioned, you still have tangent and secant. From this identity right here, I could have also done a couple of things. Instead of solving for tangent, I could have solved for secant, or not necessarily solved, but it's already secant is equal to secant of x is also equal to all of this portion right here. So let me jump from this step. Let me rewrite it. I have 1 minus tangent squared of x, and this is another approach where instead of secant, I'm going to go ahead and put this tangent squared of x plus 1. Well, I guess let me rewrite it so that you can see what I'm doing. Secant squared of x, and this is what I'm replacing. This secant, I'm replacing it with this tangent squared of x plus 1. Everything else, make sure that, leave it alone. I still have 1 minus tangent squared of x. I still have a minus in front. And now, what you can see is you're going to distribute. You're going to be left with 1 minus tangent squared of x minus tangent squared of x, and then minus 1. Now here, if I combine like terms, the 1's will actually cancel each other out. 1 minus 1 is 0. And then if I combine these two like terms, I'll be left with negative 2 tangent squared of x. And some of you might be asking, well, why didn't I just do that from the beginning? Like I said, the different approaches, especially for these trig identities or simplifying trig expressions, it takes a little bit of practice to recognize, which approach is going to give you, a better result in fewer steps. Okay? And not all the time will you know which approach to take. So you have to make sure that you're careful. This one, I decided to do just that tangent squared of x. So I use the identity and I solve just for tangent squared of x by moving that 1 over and then replacing it. There's other ways that you could have done that. Okay, but just make sure that you don't, always think that it has to be one approach and that's it.